All right, let's go over the problems from the worksheet from the weekend. Okay, we'll do some matching. This is going to go pretty quickly. So I got my pen ready. We're going to jump and just do them out of order. We'll just do some of the obvious ones. So this looks like an angle that's bigger than 90. That's an obtuse angle. So we're going to call that C. These are a linear pair. Now, some people are saying these are supplementary. That's true. But they're a linear pair. And the other pair of supplementary angles are not necessarily a linear pair. So these are really a linear pair of angles. So we're going to put B right there. Now, the other one that people were confusing was this. Okay, so this, part D, says 68 and 112. They may be a linear pair, or they may not be. Angle P and angle Y, we don't know. Actually, we do know by looking at these angles here, but the point is that these are supplementary, but not necessarily a linear pair. So this is D. Okay? These angles here, there's a 90-degree angle here, and these two angles both add up to be 90, so that is called complementary. These angles are vertical angles, they're across from each other here. So we're going to look for vertical angles, pair of vertical angles, C. Okay. These are a pair of congruent angles. That angle is congruent to that angle. So we're going to say G on that one. A right angle, there should be a right angle somewhere. I think they mean this angle here. Although, technically speaking, there's no other marks here. It's not really that obvious, but I think that's what they're talking about here, F. We would be a lot clearer on an actual test. Okay. These angles are also congruent, but that's really a bisected angle. So angle PQR is bisected, so we're going to put J there. And we have two congruent segments here. This is congruent to this. Those are two congruent segments, so we're going to put H there. Parallel lines, here's a pair of parallel lines right there. So we're going to say L. Perpendicular lines, I think, is what we're talking about here. Yes, because we're talking about lines here. So we're talking about line 1 and line 2 are perpendicular because there's a 90-degree angle there. So that's A. And this angle here is an acute angle. That's what's left. So we're going to say I. Okay, all right, let's go to the next page. Draw and label a diagram. So let's just do these quickly. We have a line segment AB with midpoint M. Put M in the middle. And to indicate that it's a midpoint, we would put two congruency marks. Okay. Draw a plane that contains 4 points A, B, C, and D with no more than two collinear points. Okay, so all they really want is that the points aren't at least obviously. Now, I like to draw legs for my tabletop so you can kind of see the plane. You don't need to do that, of course. There's your plane. And I would just draw 4 points, perhaps like this, so that none of the points are collinear. Sorry about that. Okay, this one says draw an angle EFG. Remember that the center point is the vertex. And draw a ray FP that's an angle bisector. So I'll use a different color for that. So FP, it's a ray, and it's an angle bisector. So we're going to indicate that with two congruent angles right there. Okay, what's the difference between a segment and a ray? A segment has 2 endpoints. And a ray only has 1 endpoint. And a segment has a finite length, meaning you can actually measure the length of it. An array is infinite in length. What point would be the vertex in angle BCS? It's always the middle. It's always the middle angle. So you can kind of say angle C. If you want to be a little fancier, you could say, oh no, I'm sorry, not angle C. They want the point, my bad. What point would be the vertex? So it's just point C. Okay. Determine the measure of each angle here. Okay. So these two angles here are congruent. We're told that. We've got a 40 and we've got a 70. And we know that D and 70 are vertical, right? If you want to see that a little better, make sure that's a straight line. And make sure this one's a straight line. Okay, so now you can clearly see the vertical angles because sometimes they're a little deceptive, right? So this angle here is congruent to this angle here. We'll put a single on there. So you get a 70 here. That's important. And you then can say, this is a little tough here, but you can say all the way, watch this, I'll use a different color and I'll use a highlighter too. So you can say from here all the way to here is 180 degrees. Okay, it's 180 degrees. And so far, that 180 degrees has the following angles. It has some angle that's congruent. We'll call this x. Okay, so it has an x. Then it has this 40 piece right here, so plus 40. Then it's got this 70 that we just determined earlier, so it's plus 70. And then it has another angle that's congruent to this original one, so that's also x, so plus x equals 180. Okay, and I'm not going to do all the algebra. I'll do a little quick 2x. This is 110. Subtract 110 from both sides. You get 70. X equals 35. Okay. So that makes this a 35-degree angle. We know D is 70. We did that earlier. Let's take a look here. If we go, let's take a different highlighter here. So if we go from here to here, that's also 180. So it's 40 plus 70, that's 110, plus 35, that's 145. What's left? From 145, we would have 35 because they have to add up to 180. Okay. There's a couple other things we can do. B, angle B here is vertical to 40, so we can just add a 40 there. That might have made our lives easier earlier. Angle A is vertical to this angle here, so we could put a 35 here. I think that covers everybody. They use small and capital letters here. I'm not really fond of that. These should have been each angle. You really can't name angles with small letters here and then use capital letters here, but that's the sheet that we used, and that won't happen on our exam. Okay, and C is 35 degrees. Okay, this problem here, determine the measure of each lettered angle and put in the diagram. Okay, so these three angles add up to 180. That's it's not really a linear pair. We call them linear angles because there's three of them. So 64 plus E, this E, I don't know what it is. We'll use it as a letter. Plus 90 have to equal 180. Okay, and I think that leaves 26 degrees. Check me on that, but I think it's 26 degrees for E. Okay. We got a vertical angle here to here. I'm going to undo that because it's so hard to see, but there's a vertical angle there. So we know that that angle in there is 44. And we know that F, that angle, and 78, all three are linear angles, so they make 180. So, for example, 44 plus F plus 78 equals 180. And I think that's 110, 122. That's 58 degrees. For F. Okay. Angle B and angle 78 are corresponding angles. Be careful here. Again, use the highlighter if you have one on the test tomorrow. You have a parallel line. That's too thick, sorry. You have a parallel line here, and you have a parallel line here. Excuse me, I have a cold. So that 78 and this B are both the same. See, 78. Those are corresponding angles. And angle A is a linear pair to B. So if B is 78, this must be 102. 180 minus 78. C and F are corresponding angles. There's F, there's C. They're corresponding angles with two parallel lines. So they're congruent, right? So this should be 58. And D is a linear pair to 58, so that's 122 degrees. Okay, number 3, triangle XYZ has 2 angle measures as shown. So 130 and 50, always do your linear pairs, vertical angles first. 35, 50, and you need to find a third angle, right? Again, they add up to 180. So that's 85. So this is 95. Okay, show below multiple choice. What is the angle Y? I'm sure it's D. Okay. Is that it? Yeah, let's go to 4 over here. The lines in the diagram present 4 streets in Linda's hometown, multiple choice. Keller Street is parallel to Garcia. So these guys, I would add that symbol. This is parallel to this. And Main Street's parallel to 2nd Street. So double arrows. Remember, that doesn't mean congruent necessarily. It's certainly not in this case because they're lines. If the measure of angle 1 is 95, then the measure of angle 2, well, 95, 95. Okay, those are corresponding angles. And then this is vertical, so that would be 95. And then this angle here, right there, and angle 2 are same side interior angles. Same side interior angles are supplementary, so that's what I'm writing here. And then a measure of angle 2, after you subtract 95 from both sides, is 85 degrees. What's the equation of line perpendicular to this? Okay, we did this in class. I'll go over it really quick anyway, though. Perpendicular lines have negative reciprocal slopes. So this slope is 3, so it's negative 1/3. That's negative reciprocal slopes, plus some b that we don't know. So all we're going to do is plug this point in temporarily, and then we're going to find out what b is. So you get 0 equals negative 1/3 times 0, so 0 equals 0 plus b. And that makes b 0. So to save us a little time, well, all that means is that there's no b to write, see? So it's just 1/3 x. Sorry, negative 1/3 x. Y equals negative 1/3 x. What is the equation of a line perpendicular to y equals 4? Well, y equals 4 is a horizontal line, so perpendicular to horizontal will be vertical. We write vertical lines with an x equals something. Okay, and that makes it perpendicular to y equals 4. And it's going to pass through this point. Well, all the x values are the same. So x equals negative 1 is the answer. Find the equation of a line passing through these 2 points. We'll have to do slope formula. y2 minus y1 over x2 minus x1. Okay, y2, y1, x2, y1. Sorry, did I say that wrong? Sorry. Oh, yeah, I did. y2, y1, x2, x1. Okay, I did it right here. And this is equal to negative 4 over negative 12, which is 1/3, positive 1/3. Okay, so now you know it's y equals 1/3 x. Better to keep it apart like this. Don't put the x in the bottom. Plus b. We don't know what the b is. So just like before, we're going to plug one of these points in. And I think the easiest one to plug in is going to be negative 3, 1. So I'm going to get 1, that's the y value, equals 1/3 times x. Now x is negative 3 plus b. That's equal to negative 1. Add 1 to both sides. And 2 equals b. So the final answer is what we had up here, but with the b in its place. Okay, so the final answer to 7 is y equals 1/3 x plus 2. That's from this number 2 right there. Okay, let's move on. 150 and 30. That makes this 30. Of course, they're also parallel. Actually, I don't know if they indicated they're yeah, they did. They're parallel. 125 and plus something equals 180. It's 55. Okay, so y is what? It's 55 plus 30 plus y equals 180. Subtract 85 from both sides, y equals 95. Okay, that's 95, and that's what they wanted. I think we already did that one. Maybe not. Anyway, 9. The coordinate grid below shows points, these 2 points and segment HK. What is the slope of HK? Okay, so it's up 1, up 2, up 3, up 4 over 1. Up 4 over 1, which is 4 over 1, but for short, for reduced version, we just write 4. Okay, 10. If the segment above in problem 9 is part of a line, and that line is a function of, and that line is the function f of x, find these. Okay, so f of 6 just means plug in 6 for x, but we don't have an equation. So what we're going to do is we're going to go to look at 6 and find out what f is, and f is 6. That's the y value. Okay, so f of 6 equals 6. That goes right here. Okay. For this one, f of 2, this is a little bit tougher. This is actually very more challenging, let's say. These haven't been really challenging up until now. These are a little more challenging. Well, what happens is I need to find out when this line's going to hit 2. It's going to happen way down here. If I was to extend this line here, it's going to happen somewhere down there. There's 2. And I got to see how it's going to happen. Well, the slope is 4, which we'd already determined another problem. So what's going to happen is, if the slope is positive 4, I can also go down 4, left 1, see? So it's going to take me 4 drops and 1 drop to the left. And that's only going to get me to 4. I need to get to 2. See, it's f of 2. I need to get to 2. So that's 1 drop of 4. Another drop of 4 will get me to 3. And then another drop of 4 will get me to 2. Okay? So I'm going to basically drop 4 3 times. And my starting point was 2. See, this point here is 5, 2. And I'm dropping my y value, or really in this case, my f value. Okay? So all the way down here is going to be 12 less in height. So f of 2 is going to be 12 less than this. Okay? So f of 2 is going to be negative 10. That's 12 less than 2. Okay, 2 times f of 7. So f of 7, if you go to 7 and look at f, you get 10. So this statement here is really saying 2 times 10. I'm just replacing f7 with 10. Minus f5. So if I go to 5, go up, it's 5, 2. So minus 2. And that's 20 minus 2 is 18. Okay, so that's 18. Okay, 11. Actually, let me just make sure. I think there's another problem here. Nope. Okay, good. 11. On the diagram, these 2 lines intersect at point G. Based on the angle measured in the diagram, what is the value of x? Okay, so this is 180 minus 81 minus 43. I think that's 124. So I think this is 56. Of course, you've got a vertical angle here, so that's also 56. So 56 plus x, that's this angle here, plus 90, that's a right angle symbol, has to equal 180. Okay, 56 plus x equals 90. X equals 90 minus 56. Let's pause there for a second.